Okay, so today we're going to learn about scatter plots and trend lines. You're going to be presented with a picture of a scatter plot on a graph, and you're also going to be given a sentence, and you're going to have to tell the correlation between the two data sets. But before we begin talking about scatter plots, let's make sure everybody knows how to graph ordered pairs. So to graph the point 3, 2, right here, point A, remember the first number in your ordered pair is the X, and the second number is the Y. The first number tells you how to move side to side, left or right. If it's positive, you go right. If it's negative, you go left. And then the second number is the Y coordinate, and it tells you how to move up or down. So when I go to graph point A, I'm going to go over to the right 3 units, 1, 2, 3, and then I'm going to go up to place my circle or my dot and plot point A. If I were to graph the next one right below it, point C here, this would tell me I would go to the left to -2 and then down to -1 and put my dot. Everybody good with graphing ordered pairs? Okay, on the test you will not have to create your own scatter plot. It will be provided. However, I do recommend when you are given the sentences to sort of do a sketch of a scatter plot so you can see the trend. All right, so in this lesson, in the homework, you will be creating a scatter plot, and then you'll be able to interpret it. And we're also going to use trend lines to make predictions. This is the vocabulary that you will see. Most of the questions on the test are going to have one of these 3 choices as an answer. So again, you're going to have to identify the correlation. So in this graph, or in this lesson, you are going to examine relationships between data sets. And you're going to plot points if necessary to show the possible relationship between the 2 data sets. And this would be an effective way to display some data. So here's our first example. And it's talking about the number of cookies in a cookie jar after they've been baked on day 1. So on day 1, you've baked 2 dozen cookies, so you have 24 cookies in the jar. So as the days progress, if people see a cookie jar sitting there, what do you think is going to happen to the number of cookies in that jar? They're going to decrease because people are going to come and they're going to take the cookies and they're going to eat them. Okay, they're not going to increase because nobody's baking more. So here, when you would graph it, the time is usually always on your x-axis. So it's right here. And then on day 1, notice you have 24 cookies. But then day 2, now you only have 16. And then day 3, 10. Notice the general trend of this data is going down. So this would be a negative correlation. I know they're not talking about it yet, but this is how you're going to do it on the test. I'm going to give you a picture of a graph, and you're going to tell me, is it a negative correlation, meaning the dots are trending down, or is it positive, is it increasing? Or are they scattered all over the place and there's no correlation? You'll also be given just the words and then tell me the correlation.
So that's a negative?
This would be a negative correlation, yes. Here is one with the number of points scored by a high school football team in the first 4 games of the season. Okay, it says graph a scatter plot using the given data. So here, they just wanted you to take the data and put it into a graph. Now, notice if you were to try to connect these dots, notice they go here and then they go down. But the general trend of this scatter plot is it's going upward. So it would have a positive correlation. So here is where they're actually starting to talk about the correlation, even though I've been identifying it on the first examples we've seen. There'll be 3 types of correlation. There will be a positive correlation, meaning all the dots are going upward, or a negative correlation where all the dots are going down, or all the points. So the data values increase as the other set decreases, and then no correlation, the dots are all over the place. So no relationship between the data sets. Everybody good on the 3 types of correlation? Okay, this is sort of leading us into slope. Okay, when you have a line that's graphed and it goes upward, it's going to have a positive slope. When it goes down, it's a negative slope. We won't have no correlation slopes. It'll either be positive, negative. It'll be either 0 or undefined, but that's coming up. All right, so here is a graph, and this is how you're going to be given a question on the test on Thursday. Is this going to have a positive, negative, or no correlation? Positive. Most of the dots are all heading upward. There's a couple that drop down, but the general trend here, or the correlation, is positive. So it says here, it's a correlation between the average daily temperature and beach visitors. So obviously, if it's a nice, hot, sunny day, there's going to be more people at the beach than if it were a cold day. This one is snowboarding competition, and it's showing that as the years have progressed, more people have gotten interested in snowboarding. So this also has a positive correlation. All the dots are going upward. Good so far? Okay. Here's one now, and it does not have a graph for us. So it wants to know the average temperature in a city and the number of speeding tickets given in the city. Do you think that the temperature today, is it going to have any correlation with the number of speeding tickets that the police are going to give out today? No, right? No correlation. Are they going to give more tickets on a cold day than on a hot day? No, no correlation. Okay, so this has nothing to do with each other. And this is how you're going to be presented the questions on the test, is I'm just going to give you this, and you tell me the correlation. Now, if it helps you to draw a little graph so you can see the correlation, I recommend you do that. Okay, here's another one. Identify the correlation between the number of people in an audience and the ticket sales. So here, remember, when you make your graph, if you need a visual, remember your scales need to increase. You can't start at a higher number and go down. So like, let's say and remember, it starts always at 0, 0. If you want to jump like from a 0 to a 10 or something, you could put a little squiggly to show it's a break. But 10, 20, 30, you could show the number of people, and this would be the money. What do you think's going to happen to the ticket sales and the number of people? What's the correlation? If there's 10 people, they probably only collected maybe $10. Then 20 people, $20, 30, and so on. What kind of correlation is this? Positive. So sometimes it'll help you if you draw just a quick sketch of a graph. But remember, when you set up your numbers on your X and Y axis, make sure they increase. Don't start at a bigger number and go down. Okay, here, a runner's time and the distance to the finish line. So let's say you've been running a mile and you've been running for 3 minutes. Okay, your time's going up. What's going to happen to the distance to the finish line as you get further into the race? Okay, it's going to decrease, right? So this would have a negative correlation. The longer you run for, the shorter the distance to the finish line. The temperature in Houston and the number of cars sold in Boston. Okay, does the temperature in Houston have anything to do with car sales in Boston? No. So this would be no correlation. Generally, when it's no correlation, it's going to be obvious. It's going to be silly. All right, next one. The number of members in a family and the size of a family's grocery bill. So let's say you have 2 people in your family and your friend has 5 people. Who's going to have to pay more in groceries? The 2 people family or the 5 people? The 5 people. So as you get more and more members in your family, your grocery bill or the amount you pay for groceries is going to increase. So this would be a positive correlation. The number of times you sharpen your pencil and the length of your pencil. What happens to your pencil when you sharpen it a lot? It's going to decrease, right? It gets smaller. So this would be a negative correlation. So this one, you're sharpening it a bunch of times, that number's going up, but your pencil length is going down. Okay, here it's asking you to pick the best graph. Here, you're not going to have to do this on the test, but realize that generally when we're talking word problems, we're not going to deal with the negative scale. So right away, I can see that graph A is out of there. So when you buy a car, when it's brand new, is it going to break down a lot? Probably not, right, unless you get a lemon. Okay, now, but as your car gets older, what's going to happen to the times that you're going to have to fix it? Is it going to increase or decrease? Okay, it's probably going to increase, so this would be, we're looking for a positive correlation, because as your car increases in age, so will your repair cost. So we're looking at graph B, we were looking for a positive correlation. So here they're showing age of the car can't be negative. We can't have a car that's negative 4 years old. So that's why we got rid of graph A right away. Graph B is showing positive values and a positive correlation, so it could represent it. And then they did check out graph C, but this one doesn't really correlate, so it's wrong. So the correct answer is graph B. Now we're talking about the relationship of a pie and the time it's been out of the oven. What happens to something when you take it out of the oven? What happens to the temperature?
It starts to cool down.
It starts to cool down. So we're looking for probably a negative relationship here. This one, it's still in the oven. You can't have a negative time here. So notice graph C, look at this. It's telling us that when it comes out of the oven, it's getting hotter. Is that possible? No. So here we're looking for the temperature to decrease, so we're looking for graph A. And then here they're describing each one. So graph A is the answer. Graph B, can't do it before it's taken out of the oven, so no negative time. And graph C, it's showing that it's getting hotter when it comes out of the oven, which is silly. So the correct answer there again was A. Now, sometimes you can draw in a trend line to predict something based on, the past or the graph that's been given. Now, again, you're not trying to make the line go through all of the dots, just a general trend line through as many as possible. So here, if it wants us to use the graph and predict how much money is going to be collected after 150 tickets, we're going to come over here to the tickets sold, find 150, follow it up to the trend line that we've created, and then follow it over to the money. And we can see about 750. So you can see where it hits your line and then follow it over to the other axis. For this one, they're asking us to find out how many rolls of wrapping paper. So this time we're going to look at the y-axis, find the 500, and then follow it down to the x. And we can see about 75 wrapping paper rolls. So this is used to predict. Let's look at this one. The outside temperature in the summer and the cost of the electric bill. So when you run your air conditioner, it takes up electricity. So if it's cool outside, are you going to turn on your air conditioner? No. But what if it's hot? What if it's 90 degrees outside? Are you turning your air conditioner on? Yes. So the hotter it gets, the more electric you're going to use because you're going to be running that AC. So that is going to have a positive correlation. Here, the price of a car and the number of passengers it seats. So, for example, if you have a two-seater car, is it more expensive than, say, a minivan? Okay, it could or it could not. Like you could get like a little...
The Lamborghini is a two-seater.
Exactly. Or you could get like a little Prius, okay? Which it probably seats more than two, but the back seat's probably kind of tiny. So it doesn't matter. There's no correlation. You could get a super fancy party bus and it could be a lot of money, and then you could get a two-seater car and it could cost less, or you could get a Lamborghini or a Maserati and it may only seat two people. So here, it doesn't matter the number of passengers it holds. There's no correlation. Make sense? All right. So that is your lesson. Basically, what you're going to do on the test is determine the correlation, whether it's positive, negative, or none. Again, you will be given a graph to determine those correlations and just a sentence. So your homework is both practice A and B. It is in the same assignment, and it's due tomorrow morning at 8 a.m. Any questions? Okay, so tomorrow we will learn or cover the arithmetic sequences. On Wednesday we will review, and on Thursday is your test covering lessons 3-4, 3-5, and 3-6.